I want to solve for another equation, but I'm going to use equation number 4 with 5. Okay, so I'm going to get rid of the final velocity here. So let's just say, one of the things I want you guys to understand about these equations is this. It's like you have to think about it in terms of I'm looking for something. And what you're looking for when they say solve for X, which side do you guys put it on? You put it on the left-hand side. So we're solving for the velocity in the X direction, the final velocity in the X direction. But if you were trying to solve for the initial velocity in the X direction, you put this on this side. Now on the right side, you need to be able to get those values, either through experimentation, measurement, however you're going to get them. Someone else did it and you put it in yours, however you want to do it. All right. So this is the side, this is what we're looking for. You make that choice. And this is what you have to find. You have to figure out how to get these values. In the same case, now we have two things here. And what I'm going to do is I'm going to take this delta t onto this side using I'm going to take this delta t onto this side. And now we're finding our X displacement, the positional change. But it's based on the change in time, and it's based on having knowledge of the initial velocity in the X direction, the final velocity in the X direction, and the change in time, okay, for this to take place. Cool beans. Make sense? Because it's velocity. It doesn't make sense, Jaya? You lost? Okay, it's okay. So you don't know how I got this particular equation. So this is what I did. Number 5, that's very, very good. So you see these two equations up here, 1 and 2. All I did was take the right-hand side of number 1, and I took the right-hand side of number 2, and I equated them since they're both the same kind of quantity. Oh yeah, this is delta t. Yeah, to change, I just wrote it because I didn't want to write 1, 2, 3, all those symbols. Yeah. And so you get rid of this by taking this side and putting it over here. That's where I got it from. All right, so now we have this equation, and I'm just going to rewrite this equation like so. This is going to be okay. Let's just refer to this as 5b. You know what? Let's refer to it as 6. Yeah, I'm going to refer to it as 6. I'm just trying to erase it. I don't think it likes when I make it big like this. Yeah, you say, is this 4 and 5 together? No, not yet, not yet. Almost though. So this is just 5 rewritten. So let's just say we're looking for the displacement in the X direction. Well, we need to take this to the other side. That's all that means. It's almost, I want to say it's exactly the same kind of information, but I don't want to say that because I've changed something. And now I want to replace this one, this final velocity, with the final velocity we found in equation number 4. That's what you're asking, right? Who asked that? Didn't you ask that? Oh, okay, yeah. We're going to replace this final velocity with the final velocity we found in equation 4. Oh, well, I'm saying this is 5 and this is 6. Basically, this is a rearrangement of this. So, yes, but in this particular case, I'm trying to find the displacement in the X direction. If I was trying to find t, I would do something different. I would manipulate this until I get t on the top. You follow what I'm saying? Yeah. Or if I was trying to find the initial velocity with this equation, I